This is a video for AQA Further Pure Mathematics, Calculus section 2.1, where we're looking at improper integrals, integrals with infinite limits where the integral diverges. So let's consider this integral then, where we're evaluating from 2 up to infinity. So we've got an improper integral in that the upper limit is infinite, and we'd like to know whether the area under the curve as shown on the diagram actually converges to a limit or whether it diverges, in other words doesn't reach any limit at all. Well, to do this we replace infinity with some value a and then integrate the integral with the limits 2 and a, but look at what happens when a approaches infinity. Well, integrating 1 over x gives us natural log of mod x, so we're evaluating that between 2 and a, and then looking at the limit as a approaches infinity. That will be the limit as a approaches infinity of natural log mod a minus natural log of 2. But as a approaches infinity, the natural log of a also approaches infinity, so it doesn't converge at all. So therefore we can say that 1 over x, or the integral of 2 up to infinity of 1 over x dx, is divergent. And therefore it hasn't got a numerical value. Well, here you can see a GeoGebra file of the cases that we've considered. 1 over x in this video and 1 over x squared in a video previously. The area under the graph from 2 up to a value b is shown. So the green number there, 0.25, is the area under 1 over x squared, and the red number 0.69, the area under 1 over x from 2 up to b. I can change the value of b, and of course the areas are going to increase. But what's interesting is that although these graphs look very similar to each other in that they're both approaching the asymptote of the x-axis, so that y approaches 0 as x approaches 0, the area of the under the red one, under 1 over x, keeps increasing. If you look carefully at what happens to the green one, it will slow down, and you can see that even though it is going up slightly, the rate of increase has come right down now, whereas the red one continues to increase as we go on and on. So what's happening there is that the 0.48 is getting closer and closer to the limit of half, but the 3.21 is not approaching any limit. So although these two graphs look very similar, the integral of 1 over x squared converges to the limit of half, and the integral of 1 over x from 2 to infinity is divergent, so has no value. Now that's very difficult to see just by looking at the graphs. So you must use the technique where we are trying to evaluate to a limit. So just going through that, we change the limit infinity to 1 of a, and then look at the integral with that limit a and consider what happens in the limit as a approaches infinity. That's the end of this video. In another one we'll be looking at integrals with the function undefined at a limit.